In this video, you will learn how to diagram data by using a stem and leaf plot, a box and whisker plot, and also a scatter plot. So for example 1, here we are told to find the median. And on the side here, this is what we call a stem and leaf plot, where each number here in the front is referring to the tens place, and then the numbers over here are the ones place. So for example, 0 and 2 means we have the number 0, 2, or just 2. The 0 and the 3 means we have a 0 and 3, or just 3. 0 and 7 means we have 0, 7, or just 7. And the same thing with the 1. Here we have 1 and 0 to get 10. 1 and 4 would give me 14. 1 and 4 again would give me another 14. 1 and 8 would give me 18. And I can keep going where I have 2 and 2 to get 22. I have 25, 25, 25, 29, 29. And with a 3 we have 30, 34, 34, 38, 38. And with the 4 we have 40, 41, and 47. So what we get is this long list of numbers. So that is how a stem and leaf plot works. And then from here we can use this list to find the median. So the median is the middle number. So to find that, I work my way to the center, and I find that 25 is my median. Now from the median, I can use this to find what is called the first quartile and the third quartile. To find the quartiles, what we're doing is we're finding the number that is 1/4 of the way into this list of data, and third quartile would be 3/4 of the way into this list of data, whereas the median is in the middle of this list. So to find the number in the first quartile, the 1/4 of the way through the list, we find half of the first half of numbers. So what I do is I take this first half of numbers, work my way to the center, and find the median of this first half. When I do that, I find that the median of the first half of numbers is 14. So my first quartile is 14. Third quartile is going to be the median of the second half of numbers. So I take the median 25 and I include the 25 in my list of numbers. So the 25 is part of this list. And by the way, it was part of the list for the first quartile. We included this 25 to find the first quartile. We also include it again to find the third quartile. So again, I work my way to the center to find the median of this side, to find that 34 is in the middle of the second half of numbers, which means this is 3/4 of the way into the list of numbers, and we call that the third quartile. So 34 is the third quartile. Now using the quartiles, the median, and then the smallest and largest number, we can create what is called a box and whisker plot. So here we've already found the lowest number is 2, and the first quartile we found to be 14, median we said was 25, third quartile we said was 34, and the highest number here is 47. So what I do is I can put all of this information into one little graph. So I create a number line, where on this number line I have the numbers that we need, the numbers that we have listed right here. I have those as part of the number line. So we see here a box and whisker plot where we have each of those numbers, the 2, 14, 25, 34, and 47, all here on a number line. So what I do is I plot each of those points, and then notice that I create a box around the first quartile through the third quartile. And then I put a line through the median. So right here through the middle, through the median, I put another line. So I've created my box, and then I create these whiskers going from the quartiles to the highest and lowest number. So I see a whisker here going from the third quartile to the largest number, and then this whisker, or this line segment, going from the first quartile to the lowest number. So this is called a box and whisker plot because I have box and I have whiskers on the outside. Let's try another example. Here we have, again, another stem and leaf plot. So the stem and leaf plot on the side we can convert to all these numbers. So 5, 9 means 59, 6, 3 means 63. We have another 6 and 3 to get another 63. 6 and 7 would give me 67. And then with the 7 we have 71, 76, 76, 76. We see that listed up here. Then we have 80, 80, 84, 84, and 88. And that's all listed up here as well. And the 9 goes with the 2 to get 92, goes with the 5 to get 95, and it goes with another 5 to get another 95. So what I have is this list of numbers that we've created. Now from this list, I can find the median. The median is found by working my way to the center. When I do that, the median is a combination of 76 and 80, where we can take the average of 76 and 80 to find the median. So take the average of 76 and 80 by adding and dividing by 2. That's going to give me 156 over 2, which would give me 78. So the median is 78. Now with the median, we can use that to find the first and third quartile. What I do is I basically draw myself a line through the middle of these two numbers, where now we have our first half of numbers right here, and our second half has the 80 going all the way to 95. So that's my two half of numbers. And what I do is I find the median of each side to find the quartiles. So to find the first quartile, we use the numbers 59 through 76, and we work our way to the center. Notice the median of this first half of numbers is a combination of 67 and 71. So I take the average of those two numbers by adding and dividing by 2. When I do that, I'm going to get 138 over 2, which would be 69. So the first quartile is 69. And then I can find the third quartile by again using the median and taking the 80 and working from 80 through 95. So I find the median of the second half of numbers, and I work my way to the center, and I find the median of the second half is a combination of 84 and 88. So the third quartile is going to be the average of those two numbers. So we take 84 plus 88 and divide by 2. That's going to give me 172 over 2, which is 86. So I have found the median, the first and third quartile, and I know the smallest number is 59 and the largest number is 95. I can take each of those numbers and use that to find my box and whisker plot. So the box and whisker plot is going to have a number line with each of these numbers on that number line. So here we see our number line with the numbers that we see on the side. We create a box around the third through first quartile. So from 69 to 86, we have our first through third quartile. Put a box around that, and then we put a line through the median. So right here at 78, the median, we create a line through there. So we've created our box, and now we create our whiskers going from the quartiles to the lowest and to the highest number. So we create a line segment from 69 to 59. That's our first quartile and the smallest number. And then we create a line segment from our third quartile to the largest number, which would be 86 and 95. So this here is our box and whisker plot. And by the way, there are times when our list of numbers will generate maybe two numbers being the same. For example, like your median could be the same as your first quartile, or maybe your lowest number is the same as your first quartile. If that is the case, just create what you can, and there are times when maybe there's only one box because of that, or maybe there's no whisker needed because the quartile and the lowest number are the same. So just be aware of that in case you see a situation with numbers like that. Now we've already mentioned how to interpret a stem and leaf plot. Now what if you were given a list of numbers and you were told to create one on your own? So here we see a list of numbers. Now notice this list of numbers is not in order. So what I need to do is rearrange from smallest to largest number. So when I rearrange, I now have this list of numbers right here. Once you've rearranged, you can then create your stem and leaf plot where you have this side being your stem, and this side is your leaf. Alright, so you don't need to actually write stem and leaf, you can just create your numbers, but that's where you're going to put things. So 38 would be a stem of 3 and a leaf of 8. That means 38. 39, we already have a 3 here for the stem, so we just need a 9 here for the leaf. So this means 38 and 39. Next we see 42, so the stem is 4 and the leaf is 2. That means 42. And then we also have 48, which means we need a 4 with an 8 as well. So this means 42 and 48. Next we see 50 and 55. So the stem would be 5 and the leaf would be 0 for 50. 5, 0 is 50. And then 5, 5 is 55. Alright, and then we can do the same thing for 6. We have 61 and 61, 61. So we have a 6 and then 3 ones. That means we have 61, 61, 61. And then 62, we already have the 6. We just now need a 2. And then 65, we need a 6 and a 5. And then 66, we need a 6. So right here, this would be my stem and leaf plot. Now what if you were to have a number bigger than, let's say, 99? So we have a 3-digit number. So what if we had 121, 123, let's say 130. So same thing, we have 2 different columns, the stem over here and the leaf over here. Alright, so the stem in this case would be, for 121, would be 12. And the leaf is just the ones place. So the leaf will always be just the ones place, whereas the stem could be more than just the tens place. It could be, hundreds and tens place. It could be bigger than that even. If you're in the 1,000 range, it could have 3 numbers in the front. But the leaf will always be the ones place. And then for 123, right here, the 3 is the leaf. That's the last number, the ones place. So we have a 3 for the leaf. So this means 121 and then 123. And then for 130, 13 is your stem, and 0 is the ones place, which is the leaf. So we'd have 13 here and a 0 right there. So we have discussed stem and leaf plots. We have discussed box and whisker plot. Next we have what is called a scatter plot. A scatter plot is basically just graphing points on the coordinate plane. So if you collect a list of data and you were to graph those points, we get what is called a scatter plot. So for example, right here we see a scatter plot, which is by definition a set of points that have been plotted on a graph. So this is a scatter plot, and what this does for us is it lets us see all the data very quickly in just one location. And it helps us see a picture of what we're looking at. Instead of looking at all these numbers listed, here we can see very quickly on a graph. Now with scatter plots, we can also tell a little bit about the correlation between the sets of data. Correlation simply means the amount of relationship between something. So we see with correlation the prefix co. Co means with. And then we see here relation. So this literally means with relation. So correlation, we can have different types of correlation, and what it is it's how closely two things are related. So for example, we have high versus low correlation. High correlation means there's a lot of relationship. So for example, there's a high correlation between smoking and lung cancer. So people that smoke more will be more likely to have lung cancer. Doesn't mean that they will, it just means that there's a high correlation. There's a relationship between those two things. Okay, whereas there'd be no correlation between the length of your hair and the year of the vehicle that you drive. Your hair length and your vehicle have nothing in common. Okay, so we'd say that there's no correlation between those two things because there's no relationship. Now, when you plot points on a scatter plot, you can tell whether there's high or low correlation. And then we have also what's called positive or negative correlation. So here we see 3 different scatter plots, and each one represents a different type of correlation. This first scatter plot represents a positive correlation, which by definition says that as one value increases, the other value also increases. So for example, running and calories burned. The more you run, the more calories you burn. Okay, they're both increasing, right? More running, more calories burned. So that is a positive correlation. And now here, this would not necessarily be a graph of that relationship, but a relationship like that we would get with this graph, where we see that if you were to draw a line kind of through the center of all of these points, this line would have positive slope. So because this line has positive slope, which by the way is called a trend line, it has positive slope, which means that we have positive correlation, which says that as one value increases, the other value also increases. And that's what we see happening. If you look at the x values, so left to right, as x gets bigger, so as you get more to the right, your y values also get bigger because your y values are increasing and going up. So to the right and up means that both x and y are positive or are increasing. Whereas negative correlation is the opposite of that, which says as one value increases, the other value decreases. So for example, the more you drive your vehicle, the less gas you'll have in your tank. So the driving time increases, the gas in your tank decreases. They're doing opposite things, so that would be negative correlation. And here we see a graph that would represent something like that, not completely like that because we have negative numbers. But we see here with a scatter plot that if you were to create a trend line through these points, so create a line through these points, that this line we created has negative slope. Because it has negative slope, we also know that there's negative correlation. And we see that because as x increases, so as you get further to the right, where x is bigger, y decreases, which would be going down. So to the right, the more to the right you go, the further down you're going. So x is becoming more big or more positive, and your y values are getting smaller. And then over here we see a scatter plot that has no correlation because there is no relationship, no pattern in this set of data. So this here would have no correlation. Now this is just an introduction to the concept of correlation. There's a lot more that we can use this for, but right here are just the basics. And that concludes our lesson for today. We will see you next time.